x-intercepts are referring to the x values where you are crossing over the x-axis. It is where you're intercepting the x-axis. And y-intercepts are referring to the y values where you are intercepting the y-axis. If you're trying to find x-intercepts and you're on the x-axis, then y is 0. So you're going to find them by putting 0 in for y and then reasoning out what x has to be. So in this case we just have a linear equation, and so I put 0 in for y and I'm trying to solve for the x. When you're solving an equation, you are trying to just undo all the arithmetic that is being done to your variable. So start from the outside in. I'm going to add 9 because adding 9 will cancel out the subtracting 9, and whatever you do to one side you need to do the same thing to the other side. So we get 9 then equals 2/5 times x, and to undo the 2/5 multiplying x, I could multiply by the reciprocal, or you could think of it as I'm multiplying by 5 to cancel the division by 5, and when I multiply this side by 5, again the 5 now in a numerator divides out the 5 in the denominator, and then to undo the 2 you're going to divide by 2. So 9 times 5 is 45, divided by 2 gives me 2x divided by 2, and so the x-intercept is 45/2, or 22.5. So 45/2 or 22.5. Now the y-intercept is where you're intercepting the y-axis, and if you're on the y-axis then x is 0. And so you take your equation and you put 0 in for x and reason it out. Often that turns out to be pretty simple arithmetic because you're often multiplying something by 0, and 0 times anything is 0, so that turns into a 0, and my y-intercept is -9. So if we look at the graph of this equation, here's the graph, and there is my x-intercept at 22.5, or 45/2, and here is the y-intercept, -9. Really you're talking about points, and so the y-intercept is the point x0, y -9, and the x-intercept is the point 22.5 for x, 0 for y. So again, this is your x-intercept, that point, and this is your y-intercept, it is that point. But in order to find that point, you need to focus on trying to find the value where you're hitting the y-axis, and you're trying to find the value where you're hitting the x-axis. So that was that one example. We can do some other examples here. What if I had a parabola like y equals x squared minus 11x plus 10? This particular parabola, if I'm trying to find the x-intercepts, I am trying to find where y is equal to 0. So I'm going to set 0 for the y. And solving a quadratic could be messy. I mean, you might need to use the quadratic formula. We're trying to just focus on the definition, and so we have a fairly simple quadratic here that actually factors, so we can do a little review of factoring. When I'm factoring, I'm looking for values that will multiply to give me 10, but notice that there's a positive here, and so both of these factors will have to have the same sign in order to get a positive 10. And so I want those two values then to add to 11. So 10 and 1 will work. If I put x minus 10 and then x minus 1, Notice x times x is x squared. X times -1 combined with -10 times x will give me -11 times x, and -10 times -1 is +10. So that factors correctly. And there are two values that will make y 0. When x is 10, that factor is 0. And when x is equal to +1, that factor is 0. So both of these values put in for x will make y 0. So I have two x-intercepts. One of the x-intercepts is 10, 0, and the other one is 1, 0. Again, the intercepts are technically the points, including both the x and the y coordinate. Now, if I want to find the y-intercept, that means I'm intercepting the y-axis, and so x is 0, so you replace x with 0, and in this case, that's 0, and we just get y equals 10. But again, the y-intercept is technically 0 for the x-coordinate and 10 for the y-coordinate. And if we look at the graph of that equation, here are my x-coordinates. One was at 1, and one was at 10. So 1, 10 was one of the x-coordinates. Oh, sorry, y is 0. I was getting ahead of myself. The other one is at 10, 0. Okay, so 1, 0 is one of the x-intercepts, and then 10, 0 is the other x-intercept. And we actually don't see the y-intercept, it's cut off the graph, but what did we find it to be? We found it to be 0, 10. So had the graph continued, the y-intercept value is up here somewhere, x0, y10. Looking at a couple other equations, the idea stays the same. You don't change the idea. That's kind of a good thing to think about in math all the time. The rules are set. They don't change for situations. You just sometimes have to, work with different kinds of formulas. So if we're finding x-intercepts, then we're on the x-axis and y is 0. And so if I put 0 in for y in this equation, in order to get 0, 5 is going to have to multiply 0, and the value that will make x plus 8 equal to 0 is -8. So x has to be -8, and so my x-intercept is -8, 0, and my y-intercept means that I'm looking for what I get when I'm at x equals 0, because when x is 0, you're on the y-intercept, and in this case we will get 5 times the square root of 8. And if you clean that up a little bit, remember 8 is 4 times 2, and 4 is a perfect square, so 5 times 2 times the square root of 2 will be 10 times the square root of 2. So my y-intercept is x0 and y is 10 times the square root of 2. So if we do look at that graph, here we're hitting the x-axis at -8, 0 for the x-intercept, and we actually see our y-intercept here. Again, x is 0 and y was 10 times the square root of 2. So the square root of 2 is approximately 1.41, and so 10 times that will approximately be 14.1. So again, you can kind of see that that's about where it is on the graph. And that is my y-intercept. And looking at one more example, here we don't have the equation solved for x or y. but the concept doesn't change. If I'm looking for x-intercepts, I'm intercepting the x-axis, and y has to be 0. So I put 0 in for y, and I solve for x. So I get 5x would equal 18, x would equal 18/5, and 18/5 is equal to 3 with a remainder of 3, so 3/5 is 0.6, so 18/5 is 3.6. If I'm looking for the y-intercepts, then that means that I'm intercepting the y-axis, and x is 0, so put 0 in for x, and I get -3y equals 18, and so y then is -18 divided by 3, or -6. So when x is 0, y is -6, and that is my y-intercept. And if we looked at that graph, oh, you know what, I guess we don't have that graph, but it's the graph of a line, and if, oh, here we go. So here is the y-intercept at the point 0, -6, and here is the x-intercept, and that is at 3.6, or 18/5, and then y is 0. So again, that's the x-intercept because I'm intercepting the x-axis. So there you go. That's a little review about x-intercepts and y-intercepts. Again, y-intercept means you're intercepting the y-axis. If you're on the y-axis, x is 0. X-intercepts means you're intercepting the x-axis, and if you're on the x-axis, then y is 0.